Hi guys, this lesson is lesson 11.3. It's part 1 of 2 days that we're going to be spending on this topic because it's a little complex. What we're going to be talking about today is called measures of variation. What you're going to need is the white paper that you got in class that had the measures of variation on it, and you're also going to need your orange sheet that I gave you as well, and your notebook. You're going to want to trim this down right here, and the orange one you're going to want to trim and then actually cut the 4 dotted lines so that you see these 4 doors, and you're just going to glue them so that you have the lined paper, underneath. So just like that. I hope you can see. So once you are done with that, your notebook should look like this, and you'll be ready for the notes. So pause and get all that situated, and then we'll start. So what are measures of variation? Measures of variation are ways to describe the distribution or spread of the data. What I mean by that is, similar to the distributive property, distributing data is how is it laid out? How is it spread out? And another way to talk about it is that it describes how the values of the data set are going to vary. So they describe how the values of a data set vary with just one single number. So a set of data can have lots of values. This is one way to summarize, again, but it's not summarizing the center of the data set directly, like mean, median, and mode did. Instead, it's talking about the spread or distribution, or how much is it varying, or is it varying a lot or not very much. There's 2 kinds of major variation that we're going to talk about today. One is range and one is quartiles. And quartiles is brand new to us, so it's going to take a little bit of explanation. So if you look at your orange sheet, we're going to first talk about range. So I want you to open up this first door, and again you're just going to write in behind that door on that lined paper some information, a definition. Okay? So, the range. To find the range, and what is a range? It's the difference and difference is a key word we've seen before. It means subtract, so we're going to have to subtract, and it's the difference between the greatest value and the least value. We have different names for them. The greatest value, the highest number in the set of data, is called our maximum, or max for short. Our maximum value, the highest one, the greatest one. Our least, or our smallest value, is the minimum, M-I-N. So make sure you have that max and min in there as well. Now if you close that door and you're looking at just your orange sheet on your paper, hopefully, and I should have mentioned this before, so I'm mentioning it now, make sure you have that barn door, that orange sheet glued on the left-hand side, and you'll have a little bit of space on the right. So on the right, we're just going to do the shorthand version to find the range. We're going to take the maximum value, and we're going to take the minimum, and we're going to subtract to get the range. So you should be able to close the door and not see the definition, but still be able to see the shortcut. Basically, range, max minus min. Next one. This is on your white sheet. So I am hopping around just a little bit. because quartiles in general, I wanted to talk briefly about before I do an example. So quartiles are values that divide the data into 4 equal parts. Just like quarters, and they start the same. Quartile, quarters, have that Q-U-A-R in front of it. So I'm going to show you an example. You don't need to write anything down. I just want you to watch. It's a little bit of a process, so that's why I'm going to just do one to start and talk about what do I mean by quartiles, or how do we divide data into 4 equal pieces. So this is how we divide it into 4 equal pieces. We have a data set, it is not in order. If it's not in order, we do have to put it in order. We're going to have 11, and I'm going to cross off my numbers as I do that. That's a really good trick, so that way I know I'm using them all. Then I have 15. Then I have 2 17s. I'm going to cross those out. And then it's 18, 19, and then I have 3 21s left. Okay, so I'm going to use some different colors to help you see what's going on. The first thing we could do with this data set to find a measure of variation is to find a range. So the 21 is the maximum, the 11 is the minimum. So if I subtract them, I would get the range. So our range is 10, 21 minus 11. Then, as you can see, I've outlined some steps here. We're going to find the median. And we did that from our last video. So we're going to, I'm going to underline so I can keep track that way. So 21 and 11 is one pair. 15 and 21 is the second. 17 and 21. And 17 and 19. And so I have one number in the center. That is my median. Okay. After we find the middle, we have just now split it into 2 groups. I have a group to the left and a group to the right. So I have 2 pieces. I need 4. In order to find 4 pieces, I'm going to take these numbers that are below 18, and I'm going to find the median of the lower half and the higher half. So I know my steps say number 3 first is the higher. So let's do the higher first. So 19, 20, 21, and 21, I have to find the median of those 4 numbers. So 19 and 21, and then I have these 2 in the middle. So 21 plus 21 divided by 2 is ending up going to be just 21. So that is our second division, and this has a special name that we'll get to. We're going to call that Q3, because we're dividing it into 4 equal pieces. I'm going to do the same thing on the bottom half. So I have 2 equal groups. So these 2 are the middle numbers of the second half, and right directly in the middle of 15 and 17 is 16, and that we're going to call Q1. So I know you don't know what Q1 and Q3 is. Let me explain that a little bit. So what I've done here, I'm going to use pink so that you can see it. This spot 16, this spot 18, this spot 21 has just divided this whole spread of numbers into 4 equal pieces. And if you see the 4 boxes, here's the first box, second box, third box, fourth box. These Q1, the median, and Q3 are the end of each box. So this is the first box, here's the end of it. Here's the second box, we're going to actually call this Q2, so the median is also Q2. Quartile, Q stands for quartile, so the first quartile ends at 16, the second quartile ends at 18, the third quartile ends at 21, and then we have the last one. So we have 4 equal groups, and that is what we have to do in order to find what's called the interquartile range. I know I'm throwing a lot of words out at you, but basically we care the most about the inside 2 quartiles. We want to know what's close to the middle. What's close to the middle is this quartile and this quartile. We don't really care about the end ones as much. So in order to find the range of numbers from the 16 to the 21, we're going to have to do something later with Q3 and Q1, and that is to find the difference, just like range, and it's to subtract. So when I talk about the interquartile range, I'm talking about the inside two quartiles closest to the center. Okay? So I know that was a lot. Let me, we're going to write some definitions down in our orange notes, and then we're going to do some examples, and you'll see what I mean through those examples. So let me erase this really quick. So I want you to open up the door that says upper quartile. The upper quartile is the median, and you're writing this in the line papers underneath, just like for range, is the median, which means the middle value, the upper half. This is going to always exclude Q2, which is the median. So if you close the door, on the outside, you can write Q3. So write Q3 on the outside of the door. So basically, once you find the median of the entire thing, in order to find Q3, you have to take the upper half and find the median of those, but you can't use Q2. Okay? So now, what's the definition of a lower quartile? A lower quartile, so open up that door, is the median of the lower half. And again, if I ever go too fast and you're still writing, just pause it, rewind a little bit, and pick up where you need to. Excluding again, you can't count Q2. The shortcut name for this, like we talked about before, is Q1. Okay. And the last vocabulary word that's new is called the interquartile range. So after you have 4 sections, really the one that we're most interested in is those two that's closest to the median. So the interquartile range, we also call it the IQR. So you might want to jot that down too. The IQR is the difference, just like range, we're finding a difference between not max and min, that's for range. We're going to take Q3 and Q1. So between the upper quartile and the lower quartile. So the shorthand way to remember it, you close that door, on the margin you're going to write Q3, Q1, we subtract it, we get the IQR. Okay? So make sure you have that in your notebook. We're actually going to turn the page after this, and we're going to just have a blank page. There's nothing to glue. There's nothing really to do except for to write what I'm doing. We're going to do some examples together, just 2. So in my notebook, it's page 71. If you're not on the same pages as I am, for whatever reason, just turn to the next page and write examples up the top. Here we go. So I'm going to put the numbers in order for us just to save some time. Here's the first example of 2. So here are our data numbers. We have a 1, a 2, a 3, 2 4s, and a 5 and a 6. I'm keeping it a little simple because this is complex. First thing I want to do is label the max and min. So the 6 is our max, our 1 is our min, we were asked to find the range, 6 minus 1, our range is 5. So I'm just going to put that in here. Range, 6 minus 1, or 5. But I really want to go over the IQR, or the interquartile range. In order to do that, first thing we have to do is find the middle value first of all of these numbers. So we have one pairing here, and we have a second pairing, we have our third pairing, we have an odd number of data numbers, so we have one number that's directly in the middle with 3 numbers on each side. This is the easiest one to do because there's no other calculations. So this is the median, which is also known as Q2. Okay, so make sure you're writing this down with me. Now, I'm going to switch my colors here. I'm going to go to the upper 3, the 4, 5, and 6, and find the middle value of these upper 3. When it's 3, there's 1 on each side, this one and this one, which leaves the 5 as Q3. And it's important to label each of the numbers so you keep them straight. I'm going to do the same thing over on the left. Again, still 3 numbers, which means our 2 is the middle value of the lower quartile, or the lower half, excuse me. And so this is going to be Q1. In order to find the IQR, we're going to take our Q3 and Q1 and subtract. So we have 5 minus 2, so our IQR is 3. Now, what does this even mean? It means that our numbers that are closest to the median, from 2 to 5, the range of that is about 3, which is a very small number, which means we don't have a lot of variation. So the smaller the IQ number, it means that the data numbers are pretty close together. That's basically what we're talking about. So now I'm going to erase this, go on the bottom half of your page for your second example. I'm just going to stay at this slide. We're going to do an example with an even number of numbers. It's just a little bit trickier. So here's our numbers for our second example. 0, 1, 2, 2, 3, 4, 5, and 6. So we're going to find the max and min first. Our 0 is the minimum. Label max for the 6. We're going to find the range by subtracting. So the range, 6 minus 0, or 6. And now we're going to find the IQR. In order to do that, we need to find a couple of things first. First, we're going to start with the middle value of all of them. So, I'm going to underline just so that I don't cross out the numbers. Here's the first pairing, 1 on each side. We're going to work our way to the middle. Second and third. Now we have 2 numbers in the middle. Halfway in between 2 and 3 is 2.5, or we could add and divide by 2. 5 divided by 2 is also 2.5. I'm going to draw an arrow, and I'm doing that on purpose. I want you to as well. This is the median, which is Q2, and we are labeling that 2.5. This is not part of any of our data numbers. We need to find this though, so we know where our middle point is. Now we have half of them on the left, half of them on the right. Because this is 2.5 is not a black number, it's not one of our original data points, we now have to use all 4 numbers to find the Q3, and we have to use all 4 numbers, including this 2, that we use to help us find the median. We have to use this to help us find the median of the lower half. So let's do the upper half first. We have a 3 and a 6. That's our first pair off. So I'm just going to check them off so I can see that I'm narrowing it down. And now again, I have these 2 numbers in the middle. So I have to find the middle of those two numbers again. Way between 4 and 5 is 4.5. I'm going to draw another arrow. This is the point where Q3 ends. The third quartile ends at 4.5. We need to know that boundary. And now we're going to do the same thing over here. We have 2 and 0. This is too squeaky of a marker. And now we have two numbers again that are in the center of the lower half. So halfway between 1 and 2 is Q1, which is going to be 1.5. Gotta switch markers. Too squeaky. So we have all of the things, the items that we need in order to find the IQR. The interquartile range is this range in between the Q1, end of Q1, and the end of Q3. We want this space right here and this space right here. It's technically this space. All right, got a little crazy on my circle. So in order to find the IQR, we have to take 4.5, which is our Q3, subtract it from our Q1, and we get 3 as the IQR. Now what does that mean? It means that the values of these black numbers are very close together. Our range is only 6, which means we're not talking about like 0 to 1,000. That would be a huge range. We're just talking 0 to 6. So our interquartile range, the range of the middle guys, is not going to be that big either. So the smaller the IQ number, it just tells you the less varied the numbers are in your data set. So last thing, you have an example that you can try. It's an optional. We are going to talk about this all day tomorrow. We're going to practice until we get it. So I'm just going to show you what that is. If you have room on that sheet that you were working with, writing this example down, you can do it on the bottom, very bottom. If you don't, you can turn the page. Well, basically, it is to do the same thing. Find the measures of variation, including the range. You have to find the Q2 first, the median of the whole thing. Find Q1 and Q3, and then use your subtraction to find IQR. Here are your numbers. I will see you tomorrow.